have a couple of quick sessions on basic lathe operation. Any good robotics geek needs a little tiny lathe. If you want to take small parts and have them machined at some machine shop, $65 an hour is probably minimum that you're going to pay. And if, who wants to do that when you can make them yourself at home and have all the fun? So what we have here is Jerry's little tiny central pneumatic, central machinery lathe. This is a 7x10 from Harbor Freight, is it?
Correct.
And I've kind of set it up on this wobbly table and a few of the bits and pieces that one needs. These things aren't really, you got to be careful with the lathe. Even a small one like this will hurt you bad. Big ones will kill you. I spent 15 years working on big ones, so you always have to pay attention. Of course, first thing, always have safety glasses. No safety glasses, don't even bother. These things throw metal chips. Sometimes they're hot and they will pierce your eye. Gotta have some calipers. I prefer mechanical calipers. Batteries never go dead. You can drop them quite a few times before you have to replace them. This pair I've had for about 7 years. Brought some micrometers. There's a little Fowler set of micrometers. Most of your work will probably be on a 0 to 1 inch micrometer. This set has been through Alaska and Washington and Oregon here, and the set's been around quite a few times. And the last important piece is this book right here. This book I bought 24 years ago. I'm still using it. There you go. Machinery's Handbook. If I open this up, this thing automatically opens up to unified screw thread information. Everything you need in there to know about threads, screws, and making nuts and bolts is on these charts. And that's indispensable. And cutting gears, chain, you name it, everything is in here. Tool steels, speeds and feeds, and reamers, and worth its weight in gold. So let's look at the basic lathe, and we'll look at a few things here. This one, I'm not going to say super high quality, and it's really new. Hasn't had that much use, and it's real tight and it's not really broken well. Of course, we have the bed along here, which the carriage will slide back and forth on. It's kind of stiff. It needs to be adjusted, of course. We have a tailstock. We have the live center. This is live because this is on a ball bearing and spins. And this goes in and out. When you need to support a long piece of metal, you'll run it between this point and the chuck so you can cut it. We have our carriage here. We have compound here. And we got the on-off switches and everything. So let's cut a little piece of aluminum here, and then I'm going to see if I can get this thing to cut some threads. When you're cutting threads, we've got a little piece of high-speed steel. The tip is getting ground at 60 degrees here. And we're going to put this in. This is one I just happen to have in my toolbox. It's a little big, but it'll do the trick. The rest of the operations, it's just spacing parts off and then making smaller, making a step or whatever you need to do. If I put a chuck in place of the live center, I could drill a hole down the center of the part. Gear. Now we're going to slow down here because we're going to be going at 13 threads per inch. The carriage is going to travel pretty quick. And there's a counter down here that's rotating, and this will keep me in time when I engage.
Can you point to that again?
Now there's that counter there. That's counting off of the screw, which is underneath here, when I engage this lever, I want to be lined up on the same number every time, preferably. And it's all depending on the math for the threads you're cutting. The 13 threads per inch, since that's an odd number, we should be lined up. If I was doing something like 20 threads per inch, we could probably use any mark. So what I'm going to do is move some of our part. We're going to make a little chip on our part. Just a little tiny line until it touches. About there. And then I'm going to set the dial down here to 0. And when we feed in, when we're cutting the thread, we're going to be feeding in at a half of 59 degrees. Because the tool is 60 degrees, we don't want to be rubbing on the back side. We want to be using this front face here, along the front face of the tool every time it goes in. So the tool is going to be traveling this way every time it cuts in. On a huge machine with lots of power, you can plunge the tool straight in, but that's generally not recommended. Down, I'm going to go in about 5 thousandths here. Wait till the counter comes around on one. Make a nice slight scribe cut. Pull this out. You have to watch this little machine. There's a finger catcher right there. My fingers are too big to be caught in there. Anyway, so I've gotten in 5 thousandths. Now I'm going to look to make sure that my threads per inch are correct. And if I get in my box of goodies, I'll get out a thread checker. I'm thinking this part because this is metric. I didn't bring the English one. So we'll check and make sure that the each line lines up with the threads, and then we'll make sure you have.
It's like a little comb, isn't it?
Yeah, it's a little comb, and this one's a metric. And this is 200 and this is 2.5. You can see right there. You got all these threads. These are all screw thread sizes in metric. So this is 2.5 threads per millimeter. Here's 1.8, 1.76, all the sizes for metric. In standard, you'll have 20 threads per inch, and 13, 14, you'll have all the numeric sizes. So now let's see what we can continue. We like the threads. They come out correct, because you never know. You got to make sure you got the math correct. It's very easy, especially on this little machine, to change the gears on the back side of the machine, which you can't see. You have a whole bag of gears, and you have to do some. You have to look at a chart, set all the gears up. So let's see about cutting. We're going to continue cutting now. I'm going to slow this thing down so I can pull the tool out. So now what I do is I bring the tool almost up, and I bring this back to 0. And it should be cut in a little bit. It doesn't. There we go. So I'm going to bring this back to 0. And I'm going to add another 5 thousandths here. Watch the counter come around. And we'll start at 1. And we're going to start feeding in. So we want to stop. And then I have to
Now, give us an idea as you show these of what's a good beginner's piece, because everybody's excited about buying one of these little mini lathes.
material you're using. This would be on the end like here. You machine it down, you come back, you cut it down, rough it, you rough it, and then you come down, you make your step, you cut this diameter, and then you cut up to this step, and then you'll come around and do this radius. Then you'll come in and put the groove in. And then you'll use a cutoff tool.
Will you come back and show us how to,
Oh, yes.
to make more parts? And
Oh, yes.